If you like our video, click the like button. Click the subscribe button to receive updates on our new video. Don't forget to share our video too.
Hello friends, today we'll be talking about regression analysis. Yes, now what exactly is regression analysis? Regression analysis is the technique of finding the missing values of one variable when the value of another correlated variable is given. Now, to find the missing values, we require regression equations. Now basically there are two methods. The first one is the least square method, which we won't be discussing right now. We'll be talking about the second method, which is the deviation from the mean method. Now there are two types of regression equations. The first one is called the y on x regression equation, and the second one is the x on y. Now the format for y on x is y minus y bar equal to byx into x minus x bar. And the x on y equation is given by x minus x bar equal to bxy into y minus y bar. Now, where do we use the y on x equation? The y on x equation is used to find the missing value of y. Yes, so we use it to find the missing value of y on the given value of x. So when you have to obtain the value of y, we use the y on x equation. Likewise, the x on y equation is used to obtain the missing value of x. So we find x using the given value of y. So that is the purpose of x on y. Now to obtain the regression equations, we have to perform these general steps. So remember the general steps to obtain the regression equations. Now for that, we first need to find the mean of the x values. Yes, the mean of x values, that is x bar. Next is the mean of y, that is y bar. Then the regression coefficients byx. Next will be bxy. Now once we have all these four, then we can obtain the y on x regression equation. And lastly, we could also obtain the x on y regression equation. Now let us study the various formulae to find the regression coefficients. Now please remember that r squared, the correlation coefficient r, that is r squared, is equal to the product of the regression coefficients, that is byx into bxy. So we'll just prepare a table wherein you have the formula for r, byx and bxy. Now do you remember the very first formula for r? What was that? R equal to covariance of xy, yes, upon standard deviation of x into standard deviation of y. Now basically you just have to square this and then just split it into two. That we'll do it later. Okay, let's see the next one. What was the formula for r? The second formula? Summation of x minus x bar into y minus y bar upon n into standard deviation x, standard deviation y, right? The third one was summation of x minus x bar into y minus y bar. You remember? Okay, so it's under root, perfect, under root summation x minus x bar square into root of summation y minus y bar the whole square, perfect. And there was one more formula for r. What was that? It is n times summation xy minus summation x into summation y upon, yes, upon under root, remember, tell me, it's n summation x square minus summation x the whole square, perfect. You have one more root for y, and that is n summation of y square minus summation y the whole square. Now we just have to split this into two and you get byx and bxy. So let's begin with byx. Now the first formula for byx is equal to covariance of xy, okay, upon, you have this x term there, so standard deviation of x, just square it. Yes, standard deviation of x the whole square. Likewise bxy, we write it as covariance of xy. Now standard deviation of y, just square it. Okay, standard deviation of y the whole square. The second formula for byx would be summation x minus x bar times y minus y bar upon n. Again, standard deviation of x, just square it there. Yes, so you have sigma x the whole square. Likewise bxy equal to summation x minus x bar into y minus y bar upon n and then square sigma y, so you have sigma y square. Perfect. Let's move to the you can say the third formula. So numerator remains the same, summation x minus x bar y minus y bar. Then you have the x term there, okay, just square it, so the root gets eliminated, so you have summation x minus x bar square. Easy, right? Then next is bxy, so that would be summation x minus x bar y minus y bar upon, again square of the root, so you get simply summation y minus y bar square. And the same process could be followed for the last formula. The numerator again remains the same. You see the numerator is the same as r, correct? And denominator you will just have the x term without the square root, so it is n summation x square minus summation x the whole square. And for bxy again the same story, so numerator remains the same, that is n summation xy minus summation x into summation y, and denominator you have to write the y term without the square root, so it is summation of rather n summation y square minus summation of y the whole square. Now there is one more formula for byx which we often use. Byx is given by r times sigma y upon sigma x. And for bxy we have r times sigma x upon sigma y. So these are the formulae for byx and bxy. Okay, we now study a few basic properties of the regression coefficients. Yes, the regression coefficients, that is byx and bxy. Now please don't forget that r is the correlation coefficient. So you have a single correlation coefficient r, but there are two regression coefficients, right? Now the first property is very simple. Okay, now the correlation coefficient, remember r and the regression coefficients, that is byx and bxy, they have the same sign. So byx and bxy have the same sign as that of r. The second property is, if the value of byx is greater than 1, then bxy, the value of bxy must be less than 1. So that's the second property. The third property is, the product of the regression coefficients, that is byx into bxy, must always be less than or equal to 1. Now the fourth property is, okay, when you take the average of the regression coefficients, so the absolute value of the average of the regression coefficients, that is modulus of byx plus bxy by 2, must be greater than or equal to the absolute value of r, the correlation coefficient. Now one more important point is that if you want to find the acute angle between the two regression lines, right? So when the two regression lines intersect, and if you are interested in finding the acute angle, say let the acute angle be theta. So how would you obtain the value of theta? Well, for that you have a very simple formula. So to find the acute angle between the two regression lines, we simply use the formula tan theta equal to modulus of, now modulus of which value? The product of the regression coefficients, that is Byx into Bxy minus 1 upon the sum of the regression coefficients, that is Bxy plus Byx. So this is the basic concept of regression analysis. Like it, share it, and subscribe our channel for more such interesting videos in future. Thank you.